In this video, we will see virtual memory and demand paging mechanism which used to implement virtual memory. Virtual memory is a storage allocation scheme in which secondary memory can be addressed as though it were part of the main memory. The addresses a program may use to reference memory are distinguished from the addresses the memory system uses to identify physical storage sites, and program generated addresses are translated automatically to the corresponding machine addresses. The size of virtual storage is limited by the addressing scheme of the computer system, and the amount of secondary memory is available not by the actual number of the main storage locations. It is a technique that is implemented using both hardware and software. It maps memory addresses used by a program called virtual addresses into physical addresses in computer memory. All memory references within a process are logical addresses that are dynamically translated into physical address at runtime. This means that a process can be swapped in and out of the main memory such that it occupies different places in the main memory at different times during the course of execution. A process may be broken into a number of pieces, and these pieces need not be continuously located in the main memory during execution. The combination of dynamic runtime address translation and use of page or segment table permits this. If these characteristics are present, then it is not necessary that all the pages or segments are present in the main memory during execution. This means that the required pages need to be loaded into memory whenever required. Virtual memory is implemented using demand paging or demand segmentation. The process of loading the page into memory on demand is known as demand paging. Here, whenever the page fault occurs, which means whenever the page is not available in main memory, there is a demand for that particular page. So, we are going to load that page from the secondary memory to the primary memory. Here, this process includes the following steps. The first step here is, if the CPU tries to refer a page that is currently not available in the main memory, it generates an interrupt indicating a memory access fault. Okay. Second point, the operating system puts the interrupted process in a blocking state. For the execution to proceed, the operating system must bring the required page into the main memory. The operating system will search for the required page in the logical address space. And then next step, the required page will be brought from logical address page to the physical address page. The page replacement algorithms are used for the decision making of replacing the page in the physical address space. And then the page table will be updated accordingly. The signal will be sent to the CPU to continue the program execution, and it will place the process back into the ready state. And then page fault service time. The time taken to service the page fault is called page fault service time. The page fault service time includes the time taken to perform all the above 6 steps. Let main memory access time is M. Page fault service time is S, page fault rate is P, then the effective memory access time is equal to P multiplied by S, which is page fault rate multiplied by page fault service time, plus 1 minus P, which is page fault rate multiplied by main memory access time. Here, advantages of demand paging includes more processes may be maintained in the main memory, because we are going to load only some of the pages at any particular process. There is room for more processes. This leads to more efficient utilization of the processor, because it is more likely that at least one of the more numerous processes will be in the ready state at any particular time. A process may be larger than all of the main memory. One of the most fundamental restrictions in programming is lifted. A process larger than the main memory can be executed because of demand paging. The operating system itself loads pages of a process in the main memory as required. It allows greater multiprogramming levels by using less of the available primary memory for each processes. Here, swapping. What is swapping here means? Swapping is a process out, means removing all of its pages from the main memory or making them so that they will be removed by the normal page replacement process. Suspending a process ensures that it is not runnable while it is swapped out. At some later time, the system swaps back the processes from the secondary storage to the main memory. When your process is busy swapping pages in and out, then this situation is called thrashing. In next video, we will see more about thrashing and techniques to resolve thrashing.